Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. While Agentic AI, autonomous systems that can independently plan, reason, and act to achieve goals, represents a significant leap in artificial intelligence. Its current incarnation is increasingly viewed not as the ultimate future of AI, but as a crucial, albeit flawed, stepping stone. Despite the excitement, a significant body of research and a growing consensus suggests that today's agentic AI, particularly those powered by large language models, are not the summit of artificial intelligence. Instead, they are a critical but flawed stepping stone. Let's first delve into the technical underpinnings. The agentic capabilities we see today are largely powered by large language models. While these models are incredibly sophisticated, their power comes from statistical pattern recognition, not from genuine reasoning or understanding like humans possess. This isn't a superficial bug. It's a fundamental characteristic of how they are built, leading to profound limitations that directly impact their utility and safety. First, the black box problem. It's more accurate to call it the opaque mind. These models develop internal logic that is not explicitly programmed, but emerges from their training data. This isn't understanding, it's sophisticated mimicry, and it's inherently fragile. Let's illustrate this fragility. Consider an autonomous shopping agent. You ask it to find a cheap microphone good for meetings. It scars the internet, skillfully matching keywords and analyzing reviews. But what if a genuinely superior, more affordable microphone is released? If that product is described using synonyms like budget-friendly and praise for vocal clarity, our agent might completely overlook it. Why? Because it's optimizing for the words cheap and meetings, not the concepts of affordability and suitability. This reveals a fundamental lack of common sense understanding, making these agents prone to missing obvious solutions. Next, we confront the stochastic parrot problem. Stochastic simply means randomly determined. LLMs are, at their core, probabilistic machines. They predict the next most likely word or action. This means that if you ask an agent to perform the same task twice, you might get to slightly different approaches and the different outcomes. For creative writing, that's a feature. For critical business operations or safety-critical systems, it's a catastrophic flaw. To see this in action, imagine a financial agent tasked with summarizing the key risks from a quarterly report. If you run that task 3 times with the exact same input, you might get 3 distinct outputs. One summary emphasizes supply chain vulnerabilities, another highlights regulatory hurdles, and a third gives a more generic overview. Beyond the technical, agentic AI introduces a whole new host of ethical and societal dilemmas. These systems are designed to achieve goals, but they don't possess innate ethical intuition. They optimize based on their programming, not on a moral compass. This means that their autonomy, while powerful, directly collides with our need for accountability and fairness, creating profound questions that our technology and, frankly, our society is not yet equipped to answer. Furthermore, agentic AI acts as a bias amplification engine. It's not just about passively reflecting the biases in its training data. An autonomous agent can actively learn and exacerbate them. It doesn't just reflect historical bias. It independently operationalizes and amplifies it into a discriminatory policy. Let's cement this with an example. An autonomous recruiting agent is fed 20 years of a company's hiring data. If that company historically favored male engineers, the agent learns a statistical correlation. Being male is associated with being a good candidate. The agent, without any malicious intent, learns that maleness is a statistical feature of a good candidate. It then autonomously begins to prioritize male applicants, or even deprioritize resumes that mention affiliations with women's colleges. And due to its opaque nature, detecting and correcting this becomes incredibly difficult. So, where do we go from here? This isn't a call to abandon agentic AI. It's a call to evolve it. The path forward involves consciously designing AI systems that are not just intelligent, but also trustworthy, transparent, and collaborative. We need to move towards integrated hybrid intelligence systems where the unique strengths of both humans and machines are leveraged effectively. Our first crucial step is explainable AI, or XI. It's about translating the AI's internal, complex logic into plain, human understandable language. Instead of an agent simply saying, sell stock X, an XI-enabled agent would articulate why. Sell stock X because its debt-to-equity ratio has increased 30% this quarter, historically correlating with a 15% price drop in similar companies. This allows human experts to critically evaluate the AI's reasoning, build trust, debug issues, ultimately making the system more accountable. Next, we move to neurosymbolic AI, what I call the whole brain approach. Current LLMs are fantastic at learning patterns, much like the intuitive, artistic side of our brain. But they often lack the logical, rule-based reasoning of our symbolic intelligence. Neurosymbolic AI seeks to combine these, leveraging neural networks for pattern recognition while integrating symbolic AI for logic, facts, and causal reasoning. Finally, and perhaps most importantly, human-in-the-loop AI, the collaborative future. This approach shifts our perspective from AI as an autonomous replacement to AI as a powerful augmenter of human intelligence. At critical junctures, or for high-stakes decisions, a human expert steps in to provide context, apply ethical judgment, exercise intuition, and ultimately bear the accountability. This isn't about replacing humans. It's about amplifying their capabilities. Consider HITAL in scientific research. An AI agent could analyze tens of thousands of scientific papers, identifying potential drug interactions or hypothesizing new material properties, tasks that would take a human researcher years. Then AI presents a short list of the most promising leads to a human scientist, uses their unparalleled domain expertise, intuition, and creativity to design experiments, validate those hypotheses, and ultimately make the breakthrough discovery. Here, AI handles the data scale. Human intelligence provides the critical insight, judgment, and innovation. In conclusion, Agentic AI, in its current state, is a foundational technology that has opened up incredible possibilities. The future demands a more sophisticated approach, one rooted in explainability, fortified by neurosymbolic integration, and critically, powered by genuine human-in-the-loop collaboration. Our ultimate goal should be to build AI that is not merely intelligent and autonomous, but also trustworthy. I am now happy to take any questions in comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.